Hey everybody, back with another Polars tutorial. I hope you're all doing real well today. Today I'm going to be talking about survey weights and specifically weighted means and how to calculate them using the Polars Data Science Library. That is an extension of the Polars library that was developed some time ago. And so in order to use this, or in order to do this at home, you'll need to have the Polars DS library installed in your environment right alongside the Polars environment. Alongside the Polars library. And so before I get into weighted means, I'll just talk about what survey weights are real quick, just in case some people have a more introductory statistical toolkit. So a survey weight, or just a weight in general, refers to how many elements a given record represents in its overall population. And so what do we mean when we say element? We just mean the thing that we're collecting data on. So in this case, this is a survey that I'm analyzing. It's a survey of college graduates, and so each record here represents a college graduate that responded to a survey. And so this record represents the number of people they represent in the overall population of college graduates. So this record here with this survey respondent with a salary of $110,000, they represent 1,773 people. This person with a weight of 60,000 represents 91 people, and so on and so forth. And so when we calculate an average, or any statistic really, we want to be sure that we're not treating each record the same. We want to treat them in accordance with the magnitude of their weight. So we want, for example, this record to be treated more heavily in the computation than this record. And so how do we do that? And so I'll show you two ways to do it. But first, before we do that, we'll just go over what the normal equation would be for a weighted average. So weighted average would be the sum of the product of the value times the weight. And the value is just the value of the column that we're considering. And so it would be the salary multiplied by the weight, and we would take the sum of all those products across the entire column. And then we would divide that by the sum of the weight. And so how does that look like when we attempt to compute this manually? And you can do this manually if you like. Here's how you would do that. So I'm not creating a new data frame or anything. I'm just doing a print. And so we would do nscg.select, and nscg is just the name of the input file. NSCG stands for National Survey of College Graduates. And then you point to the column you're interested in this case salary, and you multiply that by the survey weight. And the survey weight here is just called weight. And you take the sum of that just across the entire column. And then, so that takes care of our numerator. Now we need the denominator. And the denominator is just true div, the sum of the weights. And that will give you the weighted salary average, which is what I'm calling this column. So we will go ahead and run this and just take a look at the results real quick before we go on to the Polars data science implementation. Okay, so this data set that means college graduates who have a salary, who work for a salary and are employed, have an average salary of $89,000 in the United States. So pretty cool stuff. So this is okay. It's not difficult to program or anything like that, but this can get very labor intensive if you have, say, like 10, 20, even 30 variables that you need weighted averages for. So using the Polars DS implementation is very simple. So we start out the same. We just do the input dataset.select, and then to use the weighted mean implementation, we just do PDS dot, and PDS is just the alias I'm giving to the Polars DS package. So Polars DS dot weighted mean, and then the weighted mean function has two arguments. I'm using the keyword versions of these arguments just to be very, very specific. There's a var argument, which just refers to the column for which we want the weighted average, and that's salary. And then there's a weights argument, and you use that to point to the weights column, and so that's just weight. And so that's really all you need to do there, so that should return the weighted mean for us. And there we go. So we see the weighted mean using the manual computation right here, and the weighted mean using the Polars Data Science Library implementation show identical results, which is exactly what we'd want. And so that's how you do it with the Polars DS library, guys. That's all there is to it. This should save you a lot of time when compared to the programming of the manual computation. So that's really all there is to weighted means. If you have any other questions, definitely let me know in the comments. But thanks so much for watching, and I'll talk to you all again soon.